Angie. Hey, we're gonna learn it from Angie. She's a robot from Sweet. We're gonna learn it from Angie.
That's me. Welcome to Engineering Expo. Well, what are you waiting for? Let's go.
Hi, my name's Alexis Fitzpatrick. I'm a material and process engineer here at Spirit AeroSystems.
Hi, I'm Cindy Hoover, and I'm the Vice President of Research and Technology and Growth Programs here at Spirit.
And we're bringing Engineering Expo to you from Spirit AeroSystems, where we design and build large components for aircraft.
Today, we're going to learn about and build a structure that can withstand compression and is lightweight. Alexis, can you tell me a little bit about compression?
Yeah, compression is a force that squeezes things together. Can you think of any examples here?
Well, this pile of books is creating compression on the table, and when you fly on an airplane and you walk down the aisle or you sit in your seat, you're creating compression on the floor panels and other structures that are beneath you.
Do you think we can create something from paper to hold these books, like how the floor panels on an airplane hold you up and keep you from falling into the luggage bay?
Well, there's this ream of paper here, and we could just put the books on the ream of paper and it would hold it up great.
But airplanes need to be as light as possible. What if we could only use a few sheets of paper?
Well, I bet between us we could figure out how to come up with something. All right, it's time to gather your supplies and join us. You're going to need some scissors, some paper, tape, some round objects. It could be glue, it could be a paint container or a highlighter, or anything you might have laying around the house. You're also going to need something heavy to test with, so I suggest a nice large book.
We want to make a structure using a few sheets of paper that can hold a textbook or other heavy object about 2 inches off the floor. Let's start by cutting out 2-inch wide strips of paper. You can use your ruler to mark your 2 inches. Use your scissors to cut out 2-inch strips. Like that. We've already pre-cut some, so we're ready to go. So first we will take our round object and wrap the paper around it and tape it to make a cylinder. Like that. Now we need to make about 9 of these. Can you help me?
Absolutely. So Alexis, you mentioned that we needed to have lightweight structure for an airplane. Can you explain why we need to have lightweight structure in our airplanes?
Well, airplanes are really big, and if they're really heavy, it's going to take a lot more energy and work to get them off the ground and to fly, so we want to make them as light as possible.
I don't know, Alexis. I don't think that we're going to be able to hold up a book with just this little, tube of paper. It looks like it's going to get crushed pretty easy when I put a book on it.
That's right. We need them all to work together, and that's why we made so many of them. We're going to tape these together and create a structure. So let's place some tape around them.
May need to get some help with this step. Make sure you grab your parents or your brothers or sisters. Here we go.
So now what do you think? Do you think that'll hold the textbook?
Well, I don't know. Let's see. All right, here we go. It does hold the textbook. What do you think? Should we try one more?
Let's do it.
Wow, that's pretty impressive.
So now all these tubes are tied together and they're working together to create a structure, and this can take more compression than the single tube alone.
That's fantastic. This is really an efficient structure. Is that the kind of thing that we do with airplanes?
We do. This is an example of some of the honeycomb material that we use in airplanes in the floorboards. This is used in floor panels and all kinds of structures to be really lightweight and strong.
I can see why we use that. It's really like what the bees use in hives. It's honeycomb material.
Yeah, instead of cylinders, they use hexagons to create a stronger structure. The walls of the hexagonal cells support each other, so this piece of core is very strong. Let's put a bunch of books on it.
Here, we'll even add more. You can see nothing's even impacted by all of the weight, and it would take a whole lot more weight than that as well.
In aircraft, we use this material between the fiber composite to create very strong and lightweight panels of a sandwich. And this is very similar to what we use in the airplanes, and you're walking on it when you're on the flight.
And you can see this is our structure that we've built, and the side of this structure is what you're looking at that's in between these composite panels.
Now that we made something that can hold a textbook, I wonder what else our structure can hold.
Well, what about you? What changes to the structures do you think would improve it and allow it to hold more weight? Let's take out our engineering notebooks and consider these questions.
What other shapes different than cylinders could you try?
Or how does changing the diameter of your cylinder affect your structure? Does it make it hold more weight, less weight? Why don't you try it and find out?
Experiment and let us know. Share a photo of your structure and what you did, and you could win a prize. Until then,
see you next time.
Angie, we're gonna learn it from Angie. We're gonna learn it from Angie. She's a robot from Sweet. We're gonna learn it from Angie. We're gonna learn it from Angie. We're gonna learn it from Angie. She's a robot from Sweet. We're gonna learn it from Angie. We're gonna learn it from Angie. We're gonna learn it from Angie. She's a robot from Sweet. We're gonna learn it from Angie. We're gonna learn it from Angie. We're gonna learn it from Angie. She's a robot from Sweet. We're gonna learn it from Angie.
That's me. Thanks for joining us today. See you next time.